With this demo, we can show how eclipses are so rare. So we have the moon and the Earth to scale, and the distance between them to scale. So if you scale everything down to a yard, then the Earth is an inch and the moon is a 1/4 inch. And so this is the true scale between the Earth and moon, and you can use a flashlight to line them up and get an eclipse. And the reason we get eclipses so rarely is that this whole axis is not aligned with Earth's rotation axis around the sun. So the moon's rotation axis around Earth is about 5 degrees skewed from the ecliptic. So that's why they're not usually perfectly lined up. That 5 degrees makes a big difference when they're that tiny and that large of a scale. Okay, so here we have a flashlight and shining on the Earth and then the moon and projecting their shadows on a wall. And you can show how difficult it is to have their shadows line up, how difficult it is to actually get an eclipse. So here we have a lunar eclipse, and if we switch the meter stick around, we'll have a solar eclipse. But in either case, you can see how sensitive the alignment of the shadows is, and why eclipses are so rare.
So to get a solar eclipse, the light source has to be much further away than to get a lunar eclipse. As you can see, we have a solar eclipse, which is very sensitive to the movement of the moon and the light.